we can use the formula for acceleration to calculate acceleration, but also changes in velocity. So we're going to look at a couple example problems. We're going to analyze some graphs. We're going to do some math to figure out what's going on with an object. So let's first start by looking at a velocity versus time graph. And I'm going to draw a few distinct sections on this. And let's go ahead and label and scale. So 0, 1, 2, and this is of course meters per second. And we'll go -1, -2, and we'll go 1, 2, 3, 4, 5, 6 seconds. Okay. So if I have a velocity versus time graph that looks like that, and I'm going to go ahead and sketch in a line here, and then we're going to bring that down to 0, and then we're going to bring it past 0 to -1. Okay. That line has a couple distinct motions on it. In fact, it has 3 distinct motions on it. And sometimes we miss that this is a break right here, and we need to make sure we do that. So first I'm just going to describe what's happening. So from 0 to 1 seconds, so this is my time interval, I see that the object is moving at a constant speed, 2 meters per second, and it is moving away from the motion detector. Now, there's a lot I can do with that. Okay, we can figure out how far it moved, and we can say something about its acceleration. And we're going to do both of those. So time, velocity, direction. Now, on that one, it's a constant speed. And since it's a constant speed or a constant velocity, I can figure out a displacement if I like. Remember, we know displacement is equal to velocity times time. Okay? Which means if I know the velocity is 2 meters per second and I know the time is 1, I can say this is equal to 2 meters per second times 1 second, which is equal to 2 meters. So I know from that little bit that the displacement is 2 meters. And if I wanted to, I could get the acceleration. The acceleration is equal to the change in velocity divided by time, which in this case would be 0. Its velocity started and ended at 2 meters per second, divided by 1, which is 0. Now the unit on that is meters per second per second. Now that unit meter per second tells me how many meters per second the velocity changes by each second. And since it's 0, the velocity didn't change at all. Okay. Now my next time interval is actually going to be from 1 to 5 seconds. And the reason it's not 1 to 6 but 1 to 5 is because right there at 5 it changes direction. Remember, a positive velocity means it's moving away from the reference point, and a negative velocity means it's moving towards the reference point. So from 1 to 5 seconds I can't say it has a velocity. I can say it has a changing velocity. So instead of giving a velocity, I'm going to just say it changes. Now the direction from 0 to 5 seconds or 1 to 5 seconds is still away because it is still a positive velocity. Now the displacement there is actually tricky because I can't take a velocity times a time because it doesn't have a velocity. Now I can show you a trick. I could say, well, it averages 1 meter per second. So for this section of the graph right here, its average velocity is 1 meter per second. It started at 2, it ended at 0. The average of 2 and 0 is 1. It's a constant line, and I could say that it actually moves 4 meters. I don't expect you guys to do that, but I could actually do that the average velocity times time gets me displacement, and I could say that I could go 1 times 4 equals 4 meters. Okay? I'm more interested in the acceleration during that time interval. Remember, we found here that the acceleration was 0 meters per second per second. For this one, the acceleration, which is the change in velocity divided by time, that change in velocity is final velocity, which is 0 minus 2, so 0 minus 2 over how much time it took. 1 to 5 seconds is 4 seconds. This is equal to -1 over 2 meters per second per second. Now remember, that unit means how much the velocity changes by each second. So each second, this velocity decreased by 0.5 meter per second or became more negative by half a meter per second. So after 1 second, we went from 2 to 1.5. Then after 2 seconds, we're down to 1. After 3 seconds, we're down to half. And after 4 seconds, we're down to 0 meters per second. Each second, the velocity decreased by half a meter per second. Right here at that instant, at 5 seconds, we are not moving. We are actually changing direction. Anytime a direction change occurs, the object is momentarily at rest. Now, for this last little bit, 5 to 6 seconds, the velocity is still changing, but it's no longer moving away from the reference point because the velocity just went negative. It is now moving towards the reference point. And this line's supposed to be straight, which means this should really only be a negative half, and our acceleration is actually still negative half a meter per second because what happened was that thing moved negative, or changed its velocity by negative half a meter per second, and that took 1 second, and negative half divided by 1 is negative half, but my unit is meter per second per second. And again, the change in position there, because the velocity is changing, is not something I'm going to ask you to calculate. Okay? Now, we can use several of these equations in more than one way, right? We know that change in position is equal to velocity times time, or displacement is velocity times time. That actually comes from the definition for velocity. Velocity is equal to change in position, or displacement, divided by time. All we have to do is multiply both sides by t to get that equation. We can do the same thing with the acceleration equation. So we have another way to calculate a change in velocity, or change in velocity is equal to acceleration times time. And as long as we started at rest, if our initial velocity was 0, then acceleration times time will get us our final velocity. So I could also ask something like, hey, if something started at rest and accelerates at 4 meters per second for 3 seconds, how fast is it moving? And this is pretty straightforward. You say, all right, so I know its initial velocity is 0. I know that it's got an acceleration of 4 meters per second, and I know that that happened for a time of 3 seconds, and so I can say change in velocity is equal to acceleration times time, and so that's 4 times 3, which equals 12 meters per second. Now that is meters per second because I take meters per second times 3 seconds, so those seconds cancel, and I am left with meters per second, which does describe a velocity. So it's moving 12 meters per second after 3 seconds because each second it got faster by 4 meters per second.